Hello and welcome. This is Steve Suffoletto from SUNY Erie, formerly known as Erie Community College, or ECC. We're a two-year associate degree program called Visual Communications Technology, or Graphic Arts Printing. And in our print production lab, we have a Baum folder. So let's talk more about that folder. It's manufactured by Baum, who is now owned by Heidelberg. So the three most popular folders are Stahl, which is German-made, owned by Heidelberg, MBO, German-made, owned by Komori, and Baum in the United States, owned by Heidelberg. Baum is in Ohio, near Sydney, near Dayton, near Columbus. These are all floor models, industrial professional models. If you go to the small office or in-plant digital versions, often called tabletop or desktop models, there's Duplo, there's Horizon from Standard, there's Morgana, and there's MBM. The model that we have is called the 2018. It's a pile folder because the paper is stacked on a pile and then fed in. A more professional model would have a continuous C-shaped belt, U-shaped belt here. It's also called a buckle folder because the paper is going to come in here and buckle, as compared to having a knife, tucker blade knife, that would make the fold. We bought this in 2007 and we paid about $14,500 for it. Back here is the second station for making right angle folds. So this would just come over here. You would take this delivery off, put this right angle section on, and then put this delivery back over here. Specifications: the sheet size minimum is 4x6, the maximum is 20.5 inches by 25 inches. The speed, the maximum speed is rated at 8,200 inches in a minute. You would then want to convert this into folds per hour. So typically in production, doing a simple half fold or bifold would be around 16,000 an hour. A letter fold or a Z fold, which is two parallel folds, would be around 14,000 an hour. An 8-page signature, which is one fold parallel and then one right angle fold, is 9,000 an hour. And then a 16-page signature, which we can't do because you need a third section here, would be about 5,500 folds per hour. On our control panel here, we have a memory. If you go to the memory location P51, that's the total run hours. So we have 66 run hours on our folder. And again, if you go to the control panel display, P52 is the total number of sheets that were folded. So you have to multiply this by 1,000. So we've had 123,000 sheets folded over 66 run hours. Here's that right angle we were talking about here. Here's that right angle we were talking about. Here's a video of slow to fast run speeds. That's a misfeed or a skip. Or sucking air, no vacuum from a vacuum wheel. 2,100 folds per hour. Okay. Next slide here is our control panel. So if I go another slide forward, this handout is available to you. It's a legend or a key for all the different buttons and displays. This is your emergency stop. This is your speed control. All the green buttons are on, all the red buttons are off. So you have an on, off to turn on the electric motor drive, an on, off to start feeding with the vacuum, an on, off to turn off the air blowers. This is for your pile feeder. Bring the table up, bring the table down, stop the table. This button here is for make ready or setup. When you try to feed You can only feed one sheet at a time. If that's off, you'll feed until you stop feeding. This is sheets per hour. This is totalizer counter. This will zero out your counter. You have to hold and press. If you want to increase the space or the gap between sheets, you would hit the plus button. If you want to reduce the gap or the space between sheets, you would hit the minus button. And again, we have an explanation on the next handout here. At the feeder, again, we call this a pile folder because the paper is stacked on a vertical pile. There is a more professional model called, well, what it does, it continuously feeds the paper into the feeder on a conveyor belt in a C-shaped conveyor belt. We have a vacuum wheel. And vacuum wheels are good for gloss coated paper because a friction wheel would typically slip and slide. So just like on the Ryobi printing press, we have pile height and we have vacuum suction. This is our ultrasonic pile height sensor. This is the overall or the macro air blast adjustment. And then we have a lower pipe and an upper pipe to blow air into the pile. And these numbers here are for setting the pipes to the width of the paper feeding through the press. We don't want to have any doubles going through the folder. So this is a mechanical 2-sheet caliper choke. It has to be set for 2 sheets of paper. If more than 2 sheets of paper try to go through the folder, it will trip the folder, stop the folder. So we talked about the different types of folders. We have a buckle folder, not a knife folder. We have a floor model, not a tabletop model. Let's talk about stations and plates. We have 2 stations. The first station is for making parallel folds straight in line. And then if you attach the second station, you can now do perpendicular right angle or 90-degree angle folds. For each station we have plates. So we have 4 plates in the first station, 2 go up, 2 go down. And because we have 2 stations, we have a total of 8 plates. So these are the settings or the adjustments for the roller pressure. An interesting reminder is you always have to push the paper through the folder. You're not pulling the paper through the folder. So as the paper comes off the register table here, it'll come up, hit the stop, and then buckle and go down. So this buckle stop here is adjustable here. You would unlock it and lock it here, turn this to make it go down or up per the ruler. And if you were not perpendicular or parallel, not straight here, but cocked on an angle, you could loosen this adjustment and independently adjust the squareness of this buckle stop. Okay, so now we're looking at a schematic of the inside of the station where we have the buckle plates and the drive rollers. So this is roller 1, 2, 3, 4, 5. That's the main drive. This is the top 1, bottom 2, top 3, bottom 4. This one is set up for a 2 parallel letter fold. So what happens is the paper comes in through here. Remember, we're pushing the paper, not pulling it. We're pushing the paper. It comes up, hits the stop. The paper buckles here, changes direction, comes down, hits this stop, buckles here, changes direction. And because these gates are closed, it just follows and exits out. So because this gate is open and this gate is open, you fold here and buckle, fold here and buckle. Because this gate is closed and this gate is closed, you just exit out. So this would be called an up-down 2 parallel folds, which would make a letter fold. Okay, here's a video on how the buckle folder works.
We're here to demonstrate in layman's terms of how paper gets folded. First of all, you can see here the number 1, 2, and 3 and the 0, which is the main roll. paper will come off a paper feeder, register, pile. They're continuous. It will come down until it engages the rolls. The rolls will take it in, will come up in between the full plate or buckle plate until it hits the paper stop. Once it hits the paper stop, it will buckle or fold in between the bottom two rolls. It will come down into the bottom full plate until it hits the paper stop. Then it would actually fold the paper again. And as you see, the paper here is still coming down from register. So it's actually been folded, going down to the other full plate. So there's multiple things happening at once in the folder. Then it will exit the folder. And so it can go in and you have a folded piece of paper. So now you can open it up and you can see the different folds. And we're going to show you in a faster mode. You see?
Okay, continuing here. These are basic folds. You have a handout of this. This is a single fold, which is called a half fold or a bifold. It would make a 4-page signature. These are 2 parallel folds here. This is called a letter fold or a trifold for making a 3-panel, sometimes called a C fold. This is also a 2 parallel fold, but here we call this a Z fold or an accordion fold. This is also a double parallel fold that makes an 8-pager. You can then do a roll or a barrel fold. You could do a gate fold open or a gate fold closed, sometimes called a double gate fold. In here we have a French fold or a right angle fold or an 8-page signature. So we have 2 pages here, 4 pages there, 6 pages here, 8 pages there. Every time you fold a piece of paper, you double the number of pages. So if it's flat, it's 2 pages. When you make the first fold here, 2 becomes 4. And when you make the second fold here, 4 becomes 8. So it's an 8-page signature. This is called the head. This is called the foot. This is called the face. This is called the spine or the backbone. So once we stitch this here, you'd have to go through a 3-knife trimmer to trim off the face, the head, and the foot. Now we're at the delivery, and you can put some auxiliary equipment on the delivery. You can put a score in here where you can score or crease the output. Or if you put a perforated knife in here, you can now perf as you come out. Or if you put a slitting knife in here, you can slit these 2 apart. So you could increase productivity by running this 2 out by slitting. The conveyor belt has a variable speed adjustment on it. Our delivery has a hang-off stacker conveyor belt, and you can extend the tray in or out. Here's a remote control for start and stop the drive motor and start and stop the feeder. Okay, one concern we should have about safety with a folder is noise. So the Department of Labor and the Occupational Safety and Health Administration have laws about noise. In 1981, they passed a law saying that employers must monitor the noise level, provide free annual exams, free hearing protection, and training to employees to prevent hearing loss. The standard for occupational noise exposure is 1910.95. The harmful threshold limit is 85 decibels, abbreviated dB, over an 8-hour period. Decibels, deci is 1/10, and bells is named after Alexander Graham Bell, who invented the telephone. Decibels is a logarithmic or log unit, just like pH is for fountain solution chemistry, just like the Richter scale for earthquakes, and just like optical density for solid ink density, SID, trying to measure ink film thickness, IFT. So operators must wear safety hearing protection, earplugs or air muffs when operating loud machines for long periods of time. So let's do something interesting here. This is a hearing test. You can find these all on the internet, or you can download apps for your smartphones. what's going to happen here is when I click this start button, it's going to start the hertz from 0 up to 20,000 or 20 megahertz. This depends on your age. The older you are, the less you can hear higher frequencies. So let's start this test, and I'll tell you where I can no longer hear it. Okay, I can't hear anything past 8,500 hertz or 8.5 megahertz. I can't hear anything past that. You, being freshman students, 18, 19, 20 years old, you probably have better hearing, so you could probably hear much farther into this range. Again, I cannot hear any of these frequencies. They're not audible to me. You know, other animals like dogs can hear the higher frequency pitches, which is why you have a dog whistle. A dog whistle cannot be heard by a human, but it can be heard by a dog. So some of you can probably still hear these frequencies. I cannot. Okay. Here are some videos you can watch at your leisure, but let's take a look at this first one here. Speed, 12,200 an hour. Vacuum wheel, registered table, first buckle, right angle, second buckle. Table, variable speed, so again, pile folder, buckle folder, right angle, counter.
There's the parameters, shows the hours and that's how many hours they've run it, 229.23 hours. That's 1,360,000, or 36,000 sheets. Yeah, 1,036,000. It's got dash controller,
times 1,000.
you could dash. It's got your total count, rate per hour, a teach-in button. This is for jogging if you have multiple units. This machine's like brand new.
Okay, as always, thank you for your attention. I hope you found this content interesting and informative. Have a good day. Bye now.